Hello and welcome to this recording about a demonstration for transitioning from AWS App Mesh to Istio. My name is Eitan Suez and I am a Principal Technical Marketing Manager at solo.io. And in the context of my role, a lot of what I do involves explaining technical topics in the cloud native space. In May of 2024, Solo published a white paper titled Transitioning from App Mesh to Istio for AWS EKS. The URL or link to that white paper is here up on the screen, as well as the QR code will resolve to that URL. This white paper provides a comparison of AWS App Mesh and Istio, and as well as a practical example for migrating from App Mesh to Istio. Now, since the publication of this white paper in the fall of 2024, AWS announced that they will discontinue App Mesh in the near future, about maybe a year or two from now. And so it's apropos to perhaps revisit the white paper, and as an aid to the white paper, this recording will accompany it and will walk you through essentially the process of going through that practical example, standing up a cluster. We'll walk through it together in a moment. So if we take a look, this is just a screenshot of one of the pages in the white paper that shows the sort of the beginning description of the practical example for migrating an app that's running in App Mesh in AWS EKS to Istio. It's a relatively simple example in that it uses one of the sample apps from a repository published by AWS that demonstrates a variety of how-tos. And the upgrade happens to be a sort of in-place upgrade where we sort of deploy Istio to the same cluster and transition the workloads to be managed by Istio. And so I'm going to walk you through how that works. The sample application in question is a typical sort of demo example, a color service backed by multiple backing deployments. In this case, you can sort of distinguish between them in that each pod is assigned a different color, red, green, and blue. And that's the example app we're going to use. There's a client application that calls the service, and the main scenario that's illustrated is a traffic splitting scenario where we can configure the weights of load balancing across these three backing endpoints. So what are we going to do in this recording? We'll do a sort of end-to-end hands-on walkthrough. So if you want to sort of follow with the white paper and sort of stand up this entire environment for yourself to see how this all works, this recording will show you how. So we'll begin by provisioning an EKS cluster, and then we'll install the App Mesh controller and the CRDs, and then we'll build and deploy the sample application that we just discussed, and exercise how traffic splitting works in the context of App Mesh. And then we'll proceed with the migration. We'll install the Istio add-on from the AWS Marketplace. And then we'll migrate the workloads to Istio and show you how that all works. And we'll finally reconfigure the traffic split to match, so to speak, using Istio resources this time to show you the difference. All right, let's get started. So I'm going to step out of this presentation, and what I've done is sort of extracted the commands from the white paper in an easy to follow set of instructions, primarily for my benefit. What you see are the instructions on the right hand side and my terminal on the left hand side. We begin with a command to construct or to provision an EKS cluster. But before I get started, I want to sort of, these instructions provide you a variety of links which sort of explain where all of this comes from. Again, I mentioned that there is a GitHub repository with examples, and this is what you're looking at here, and all of these URLs will be made available. Inside this repository are a variety of instructions in terms of README files and walkthroughs, and there's a variety of walkthroughs. The one that we're going to work through is the one called the How to Case HTTP2. And there are what they call base instructions that walk you through provisioning the cluster. You won't find those instructions explicitly in the white paper itself, and that's the reason why I sort of show you these ancillary resources that are associated with this exercise. So let's sort of circle back to our instructions, and the first step will be to provision a cluster. You can sort of see what we're going to do in the outline here in this on the right hand side of my screen. We'll provision a cluster, install app mesh, deploy applications, configure traffic splitting, and so on. And so we begin with this command, an EKS cuddle command to create clusters. I can also look at my sort of current state of the world. I'm logged into AWS, and I do not have any cluster at the moment. And so I'm going to begin by creating a cluster. And there's some of the salient flags that you want to sort of I want to point out here is I'm naming my cluster app mesh test. It's going to be a 2-node cluster, potentially with up to 3 nodes, and with ECR access and app mesh access. And there's also kind of an authorization with OIDC stipulated there in the flag. So I'm going to fire that off, and that's going to essentially be provision for me my cluster. I happen to be using the US East 1 region. That's not really that material. And there's a CloudFormation stack that's being sort of invoked that is going to provision my cluster, my node group, and all the necessary add-ons for the cluster to be ready for the app mesh installation. So the next step will be installing app mesh proper, and we all know that in AWS provisioning a cluster takes a few minutes, and so I'm going to pause the recording and we'll pick up the moment we get our prompt back here in our terminal. So we'll see you in just a second. Okay, the provisioning of my cluster just finished. It took about 15 minutes or so, and you can see the log of output has definitely grown from the moment I sort of invoke the command to create the cluster, and we get a message at the bottom of the screen stating that our kubeconfig file has been deposited somewhere in my home directory, and I have my kubeconfig environment variable actually configured to point to that path. So I should be able at this point to simply perhaps just verify that my cluster is created, and maybe to submit a command such as kubectl get namespaces just to make sure that I'm actually this is actually working. We can also look at my kube context. So you can see here I've got essentially I'm pointing to a Kubernetes cluster running in AWS. All right, so that was step 1. The step 2, of course, is still part of the setup, which is to install the app mesh controller and CRDs. So let's begin with the CRDs, the custom resource definitions. Obviously, if you're familiar with that mesh, you know what those entail. You'll see them sort of outputted across the screen here. We have backend groups, gateway routes, meshes, virtual gateways, nodes, virtual routers, and virtual services. Maybe I should point out that the white paper, when you sort of peruse through it, has a nice sort of basic description of each of these resources there on page number 12, what these resources essentially are all about. Okay, so we've got the resource definitions applied to our cluster. We're going to then use Helm to install the AWS App Mesh controller in a namespace of our choosing called App Mesh System. That's sort of the convention. And that will take a fairly short time. We can look at our namespaces now and see that the App Mesh System namespace is there. And we can look at the pods in the App Mesh System namespace, and we should see our App Mesh controller running. So that's great. That was pretty straightforward. All right, the next step is actually a little bit less straightforward, deploying the example applications. There are, I mentioned there is a repository with a long list of walkthroughs that I've already checked out, and I can maybe, maybe I'll CD into it. It's called the AWS App Mesh Examples. And there's a subdirectory called walkthroughs, and under walkthroughs you can see a long list of walkthroughs. We're going to focus on the one called how to case HTTP 2. That's the one that the white paper references. And the way this works, as you're familiar with, in general, any sort of GitHub repository will typically have a README file with instructions for proceeding to deploy these applications. And I went ahead and followed these instructions. It involves essentially configuring a variety of environment variables, which I've done through an environment file. And it captures a whole list of them. Let me just make sure that one of them is actually resolved. To the VPC ID is one of the parameters necessary, and I think I can just walk out and into my directory again, and that should refresh my environment variable. Let's see. There they are. There's a whole list of them. VPC. So I can type. There we go. So that's the VPC where my cluster actually resides, the virtual private cloud. And I'll step back into my walkthroughs. Essentially the step is to invoke a script. Now, if we look inside that script, it does a variety of things. This is actually sort of an end-to-end build. It'll build my Docker images on my local machine, push them to my ECR registry, and then finally sort of resolve a manifest template and deploy a manifest to my Kubernetes cluster. It's a little bit onerous and it takes a little bit of time. We'll see how long this goes. I might fast forward this clip just for the sake of... but since I've built these images before, this might actually go pretty quickly. Here we go. Yeah, there are no changes. All right, so what you're seeing here are at the tail end of my output are the creation of a variety of custom resources, not just the deployments, but also app mesh resources. And we can take stock of what we have right now. We can sort of look at the pods. Everything is deployed to a namespace called how2khp2. And here we see our applications, blue, green, and red, and the client, just like we had in the illustration from the white paper. We can go back there provisionally just to kind of get a sense of what we're deploying. So this is it right here. Okay, and we'll do a couple of things. First thing is that I might want to do is sort of default my context to that namespace, so I can just type kubectl get pods. It's going to be a little bit easier for me. And some commands that you might want to run at this point are app mesh commands. List virtual services, for example. There's a virtual service that's defined for our color service. And there are a number of additional sort of app mesh resources besides. We can sort of look at the instructions from the README in the GitHub repository, from the base instructions, and there's a number of commands we can run. Things like AWS app mesh, list meshes, and we have a single mesh resource. And then we can likewise look at there are virtual nodes. There's also a virtual router in there. Let's just look at that just to ascertain that all of our resources have indeed been created, and they have. So let's proceed then to the next step. One other thing that's important to point out is the fact that all of these pods have 2 containers each, and so AppMesh is very similar to Istio in that it uses Envoy as a sidecar, and you can see that the sidecar injection for AppMesh has actually taken place. So now with our application deployed, it's time to test the application. The first thing we do here is show the configuration of the virtual router. So this is a wall of YAML, but if you focus on lines 24 through 40, for example, you can see that there's a configuration of weighted targets. That is, we are specifying a weight of 1 for each of the 3 virtual nodes, the backends, red, blue, and green. And so we expect traffic splitting to be fairly an even distribution of the traffic across these 3 endpoints. And we could test that. And so this exercise is strictly about traffic splitting. We're not configuring ingress. And so the sort of expedient way to go about it is to basically port forward port 8080 on my local machine to the actual client that's making a call to the color app. And we can then send requests to the client, and the client will then call the color service. And we can do this 10 times in the for loop. And it's interesting how green was selected. It seems an inordinate number of times, but we should get more or less over a period of time an even distribution of requests across all three backends. And so the first exercise that you go through in the white paper is to sort of customize the weights. Instead of using even weighting, we can specify a 50, 40 or 10 split for green, blue, and red respectively. And then we can verify that our configuration of traffic splitting is actually honored by doing a sort of a little statistical exercise. We could send 100 requests and note that roughly 50 of those requests should end up in the green bucket, so to speak. And so the way we do this here is with a simple for loop that wraps that curl request to the client, which then calls the color service. And then we sort all the responses and count the number of times blue, green, and red were called. And here you can see more or less a 40, 50, 10 split between blue, green, and red. So everything seems to be working. We've got our App Mesh environment all set up. And now it's finally time to talk about sort of how we're going to go about bringing Istio into the picture. And so again, we're following the instructions from the white paper. Here we're defining a couple of environment variables that define the name of my cluster and the region it's in. And then we'll go ahead and invoke a command, AWS EKS create add-on. Okay, so what is this about? Essentially, where the add-on solo.io Istio distro is the Istio distribution in the AWS marketplace. And we're going to apply that add-on to our cluster. And there's a number of ways to do this. Essentially, since we're in AWS, we could take advantage of the AWS marketplace. And we could see here status is creating. So our add-on has been sort of in the process of being applied to our cluster. We could have also just simply used the Istio CLI or used Helm as well, just like we did with AWS App Mesh. So there's a number of ways to install Istio. So we can verify then. First of all, there's a command here, the describe add-on command, which can tell us what the status of our deployment is, so to speak, and it's still in creating phase. And we can look at in our namespaces. We should see the Istio system namespace. And we can look at the pods in that namespace. And here we see the components of Istio, Istio-D, and CNI and the Z-tunnel. It looks like it's been deployed. We can look at the status again, and now the status is changed to active. So we know that Istio has now been installed. So this brings up an interesting question. That is, we can either choose to run Istio in ambient mode or not. In this sort of walkthrough, I'm walking you through sort of the basics of using sort of the classical Istio with the sidecar injection. All right, so how do we go now from a list of workloads that are governed, whose traffic is governed by AWS App Mesh, to ones governed by Istio? The first step was to install Istio. And the next few steps, the very next one has to do with sort of a retrofitting a few things to match conventions. And so if we look, for example, at the service name color, we can, and maybe I can do an O wide on that. We can see that it has no selector. And so the next command I'm about to run is essentially fixes that. It goes ahead and defines a selector, which is the label app equals color for that service. So if I look at the service again, now it has a selector. And the reason that's important is because our workloads, blue, green, and red, all have the label app equals color. So that's the way in which Istio understands what the endpoints for that service that back it are. It's sort of inherent. It doesn't require any extra configuration, whereas with AWS App Mesh it did. There is actually a virtual service definition there and other resources to sort of define that relationship. Here we're using a Kubernetes way of doing things in Istio. The next step will be to replace the labels on the namespace from the AWS App Mesh convention. So if we do show namespaces with labels, we'll see that the how to case HTTP2 namespace has the App Mesh sidecar injector webhook equals enabled label applied, and we're going to remove that label and replace it with Istio's convention, which is to use Istio injection equals enabled. So that's pretty straightforward. We can rerun that command and see that now we have the Istio injection label in place. And you'll see in the white paper also, if you want to look at or tailor logs of these pods, you have to turn it on in Istio with a telemetry resource, and so we can do that. And the next step is, this is really the essential one, is the rollout restart of our deployments in that namespace. And what happens at that juncture is sort of the replacement of the old pods with the new replica sets, which are going to have Istio sidecars injected instead or in lieu of the AWS App Mesh sidecars. One thing we can do here, maybe I can type Istio cuddle proxy status. This is maybe I'll do a watch on that. And that essentially will show us in sort of near real time all of the proxies, right, the sidecars that Istio knows about, that it actually synchronizes configuration with. And so if we do that, and then we'll in the top panel, what we could do is restart our deployments, we should see those workloads or their proxies come under the jurisdiction of Istio as we sort of restart our deployments. And so we've restarted them, and as they come up, we should see in the bottom panel some additional proxies added to the list: blue, green, red, and the client. All right, so that all is essentially a simple way to verify that our workloads are now sort of being managed, or at least the networking for those workloads, by Istio, and they're no longer managed by App Mesh. Right, so what we can do at this point is test the application again. We can sort of port forward again, and then we can essentially send 100 requests again to our applications, and we should see again an even distribution, because now we need an Istio configuration resource to define how we want to distribute requests across these three backends. So we see more or less an even distribution across all three. Now at this juncture, we can delete the App Mesh specific resources, the virtual services and virtual routers, virtual nodes. They're no longer being actively used for our application. And instead, the way that we do this with Istio is with two custom resource objects. The first one is a destination rule that defines subsets. And so this is a way of informing to Istio that we have three different distinct backing endpoints for our color service, namely blue, green, and red. We can distinguish them by the label named version. So again, if we look at our pods with labels, we should see that red, blue, and green have a label called version with a value of blue, green, and red respectively, and we see that here in the output, although it requires a little bit of parsing, not a big deal. So we can apply this destination rule that defines the subsets, and this is primarily informative for Istio. It doesn't actually alter the traffic in any way, and then the accompanying or companion resource, the virtual service, is where we define our weights. So you can see on the right side of my screen here, we have an HTTP route definition with three destinations with three distinct weights for the destinations green, blue, and red. And so we can apply that. And now that we've configured Istio to sort of send traffic according to that weighted distribution, we can simply rerun our little set of 100 requests and see a revised distribution of requests across those three applications. So at this juncture, our workloads are now all configured by Istio, at least the networking, the traffic management, and other aspects can also be configured with Istio, whether it's authorization or any of the other sort of things that we can do with Istio, observability and so on, are all sort of governed by Istio with its Envoy sidecar. And here we see sort of the distribution of 40, 50, and 10 requests to each of these application backends. All right, so that sort of concludes my demonstration of the practical example. I should mention that this is not the only way in which to sort of migrate. This was sort of a quick and easy way to do it. Obviously, other methods should be explored, such as the idea of maybe deploying another set of instances of these workloads that are governed by Istio and do all of the setup in advance, and then switch traffic from the old to the new application. That could be more of a sort of a streamlined revised implementation of this transition to Istio. All right, so to conclude, at this point we are free to uninstall the app mesh controller and its CRDs. They're no longer being used, although it's still installed in our cluster. And then if we want to clean up our whole environment, we can delete our cluster. So to wrap up, let me sort of come back right here to our slide deck, and I just want to share with you again the URL or the link to the white paper. I encourage you to go and read it and learn a little bit about the differences between these two, and it seems the obvious choice these days to given that AWS App Mesh is going to be discontinued, to start looking for alternatives and transitioning our workloads to Istio. All right, well, thank you very much, and we'll see you in the next recording.